you could travel to a distant star and return to Earth, only to find generations have passed and everyone you knew is long gone? That's not science fiction anymore. We're diving into the mind-bending reality of time dilation and how this bizarre phenomenon could be the key to interstellar travel. Imagine waking up after a 6-month space mission and realizing 7 years have passed on Earth. That's not science fiction. That's Einstein. And according to leaked internal concepts buried in NASA's 2050 research roadmap, this phenomenon, time dilation, isn't just a theoretical curiosity anymore. It's a tool, a classified set of documents quietly referenced in a 2024 DARPA-NASA cross-initiative hints at something extraordinary. Project Chronos, a proposal to exploit relativistic time effects for long-duration missions beyond the heliopause. If real, it would mean the first human experiments designed not to travel faster through space, but slower through time. For decades, time dilation has been the realm of equations, Lorentz factors, muon decay, and GPS satellite corrections. But now, deep in NASA's internal studies, the physics of relativity is being treated as engineering. Prototypes for near-light propulsion, cryogenic temporal shielding, and relativistic AI guidance are no longer science fiction slides. They're line items in funding summaries. So what exactly is happening inside NASA's Future Missions Office? Why are senior physicists suddenly re-examining the twin paradox as a mission planning variable? And what does temporal risk mitigation mean in a real government budget? Because if these documents are authentic and independent physicists say the math checks out, then by 2050, NASA might not just be exploring space, they might be learning to navigate time itself. Stay until the end, because the deeper we go, the clearer it becomes that this isn't just a story about physics. It's about what happens when the boundaries between time, technology, and every story about time travel starts with a clock. Not the kind ticking on your wall, but the one Einstein imagined in 1905, 2 mirrors bouncing a beam of light between them. In his thought experiment, if you set that light clock in motion, the beam has to travel a longer path. A longer path means a slower tick. That's time dilation. The faster you move, the slower your time runs compared with everyone else's. For decades, that idea sat on chalkboards. Beautiful, precise, but untested. Then, in 1971, the Phil-Keating experiment took 4 atomic clocks, flew them eastward and westward around the world on commercial jets, and compared them to clocks that stayed on the ground. When the flights landed, the results matched Einstein's math to the nanosecond. The moving clocks had lost a few billionths of a second, exactly as relativity predicted. That was the first time humanity proved that motion really bends time. Fast forward half a century. Today, time dilation is not a theory. It's infrastructure. Your phone's GPS works only because its satellites onboard atomic clocks run 45 microseconds faster per day due to weaker gravity and 7 microseconds slower because of orbital velocity. Engineers literally program Einstein into every GPS chip so your location doesn't drift kilometers off course. Relativity isn't science fiction. It's the quiet correction that keeps the modern world synchronized. But the most dramatic proof sits 400 kilometers above us, aboard the International Space Station. Astronauts orbit Earth at 76 kls, fast enough that for every 6 months they spend in orbit, they age about 0.05 seconds less than the rest of us. It's microscopic, but measurable. When astronaut Scott Kelly returned from his year in space, NASA compared his DNA clocks with his twin brother Mark's on Earth. The results showed what Einstein predicted. Time really passed differently. And yet these were slow dances with relativity, fractions of seconds, whispers of difference. To make time dilation visible on a human scale, you'd have to travel near the speed of light, 0.9 c, 0.99 c, 0.999 c, where minutes aboard a ship could equal years on Earth. For most of the 20th century that was fantasy, but in the 21st century something changed. particle accelerators began routinely timing subatomic travelers that live longer simply because they move faster. At CERN, muons, particles that normally decay in 2 microseconds, survive for nearly 20 times longer when whipped close to light speed. Their clocks slow down, their lives stretch, and the detectors record it perfectly. Nature itself keeps proving Einstein right, again and again, and this is where the story quietly turns from physics to planning. Because while these experiments confirmed relativity, they also sparked a realization inside NASA's advanced concept divisions. If time can be stretched, even slightly, then duration, aging, and mission, logistics are not constants. They're variables that can be engineered. In 2019, internal NASA think tanks began circulating proposals about relativistic logistics, how to model mission timelines when crews travel at fractions of c. At first, it was academic. By 2024, it had a code name, Project Chronos. And that brings us to the question that launches this entire investigation. Is NASA quietly designing missions that use time dilation, not as an obstacle, but as a feature? Officially, no one at NASA will confirm a program called Project Chronos. Unofficially, everyone in advanced propulsion circles knows the nickname. It first appeared in a 2024 internal abstract uploaded briefly to the NASA Technical Report Server before being pulled within hours. The title line read, Relativistic Mission Design, Temporal Risk and Human Factor Modeling, Phase 0 Study. That single phrase, temporal risk, raised eyebrows. Why would a space agency document list time as a hazard? According to aerospace journalist Michael Sheen, who archived the PDF before it vanished, the paper originated from the Advanced Concepts Group at NASA's Johnson Space Center. It described a 2050-era scenario, a crewed probe accelerated to 0.2 c, aimed at the outer heliopause using a fusion-assisted light sail concept derived from breakthrough starshot research. The goal wasn't to reach another star, it was to study how humans experience time when relativistic effects become measurable over months instead of microseconds. The report outlined 3 phases. Chronos the WEM, Simulation and Cryogenic Testing, 2026-2032. Laboratory work on temporal load modelling, testing how long-term cryogenic suspension interacts with tiny relativistic drifts in clock synchronization. One line read, Crew metabolic preservation synchronized via relativistic time offset calibration. Translation, designing cryosleep systems that compensate for the difference between the ship's clocks and Earth's. Chronos Seku, relativistic uncrewed probe, 2035-2042. A small AI-controlled craft, possibly launched from lunar orbit, using next-generation fission fragment propulsion to approach 0.05 c. Its mission objective, test data latency under time-dilated conditions. In plain terms, see how command and control works when your seconds aren't the same as Earth seconds. Chronos III, manned relativistic transit demonstrator, 2045-2050. This phase mentioned biotemporal mitigation architecture, a phrase so strange that physicists who read the leak started arguing whether it meant radiation shielding, psychological conditioning, or something else entirely. Then, as suddenly as it appeared, every copy of the report was gone. Inquiries to NASA's Public Affairs Office returned the same sentence. No active project under that designation exists. Yet the idea refused to die. Independent researchers cross-referenced funding requests in the FY 2025 NASA Technology Roadmap and found a curious entry. Relativistic mission logistics and temporal modelling, $12.6 million, no explanation, no press release. Dr. Helena Bryant, a physicist at Caltech and former NASA fellow, told Science Now, "That's enough money for serious simulation work. You don't spend $12 million studying a thought experiment." Around the same time, a separate DARPA-NASA memorandum on long-duration cognitive resilience surfaced, referencing, time perception variance in confined AI-assisted crews. If accurate, that means Project Chronos isn't just about physics, it's about psychology. How does a crew cope when their subjective year equals decades on Earth? When their families, their mission controllers, even their nations age without them? That psychological risk has a name inside NASA's Human Factors Division: temporal displacement syndrome. It first appeared in a 2030-era white paper describing the emotional strain of asynchronous communication with relativistic probes. Engineers joked about future shock in real time. Now it's being treated as a design constraint. Multiple sources close to the agency claim that Chronos simulations use AI twin astronauts, digital copies of crew profiles running at accelerated clock speeds, to model how human cognition might drift when time runs slower. Those simulations reportedly feed into training protocols for future interstellar navigators. By late 2024, even the European Space Agency quietly joined the research through its Ariane Next propulsion lab, citing synergistic modelling with NASA's temporal dynamics studies. In simple terms, Europe wanted a seat at the table, because whoever masters relativistic navigation first controls the timeline of deep space exploration. What began as Einstein's clock had become a geopolitical race. So far, everything about Project Chronos remains deniable. No formal announcement, no budget line labelled by that name, just scattered references, like breadcrumbs across technical archives. To understand why NASA's engineers are even daring to model time as a design parameter, we have to look at what's already happening inside propulsion labs today. Because the key to bending time isn't a paradox or a wormhole, it's velocity. Einstein's Lorentz factor, the backbone of special relativity, tells us exactly how much slower time runs for a moving observer. At 0.1 c, clocks aboard a spacecraft slow by about 0.5%. At 0.5 c, they lose nearly 15%, and at 0.9 c, 90% of light speed, time aboard the craft runs less than half as fast as on Earth. Every extra decimal of velocity buys you more time, or, depending on perspective, less of it. That equation is no longer academic. The Heliopause Propulsion Initiative, a collaboration between NASA, Oak Ridge National Lab and private partners, has already demonstrated plasma confinement models theoretically capable of sustained exhaust velocities of 50,000 km/s, roughly 0.17 c. In other words, within the technological horizon of 2050, human-made craft could plausibly reach speeds where time dilation becomes measurable across months. But propulsion is only half the equation. The other half is measurement, and that's where quantum clocks enter the story. In 2023, a team at NASA's Jet Propulsion Laboratory tested optical lattice clocks with stability, better than 1018 seconds per second, so precise they can detect time dilation from a 1 centimeter change in altitude. Those same clocks, miniaturized and radiation hardened, are now candidates for interplanetary missions. Once aboard a relativistic craft, they become not just instruments but witnesses, recording how time itself stretches as velocity climbs. This isn't speculation, it's engineering in progress. JPL's Deep Space Atomic Clock 2, launched aboard the Veritas testbed, already demonstrates autonomous timekeeping accurate enough to navigate without Earth updates. Combine that with relativistic telemetry correction algorithms, and you have the foundation for Chronos' so-called temporal synchronization architecture, a network where spacecraft time and Earth time are no longer identical, but can still communicate coherently. Then comes the human factor. NASA's space biology program has been quietly funding studies on metabolic slowdown, cryogenic tolerance, and cognitive preservation during hypothermic suspension. Publicly, it's about long-duration Mars missions. Privately, insiders admit these protocols are the biological complement to relativistic travel. If your body ages more slowly due to both temperature and time dilation, you multiply mission efficiency by orders of magnitude. Even today's astronauts glimpse a primitive version of this. At orbital speed, their bodies experience microseconds of delay relative to Earth, a biological tick slower. Scale that to relativistic velocities, and a 6-year flight could feel like months. From a planning perspective, it's a revolutionary advantage. Crews return biologically young to a world that has aged decades. From an ethical one, it's a crisis waiting to happen. Because time dilation isn't just physics, it's separation. Every meter per second closer to light speed stretches not only clocks but relationships, societies, and command structures. A Chronos crew travelling to the Kuiper belt at 0.2 C could complete a 5-year mission by their reckoning, only to find 8 years have passed on Earth. For mission control, that's a logistical nightmare. For the astronauts, a psychological abyss. That's why Chronos research keeps circling back to one word: synchronization. Keeping human minds, machine clocks, and ground communications coherent across diverging timelines is the true frontier of temporal engineering. And it explains why the Department of Defense suddenly cares about relativistic telemetry. If your opponent's data stream runs even slightly out of sync, control collapses. So yes, by 2050, NASA's ambition may not be to build a faster rocket. It's to build a coherent timeline, a way to keep humanity tethered to itself while stretching time to its limits. And if that sounds abstract, remember, every new clock NASA launches into space is already a small act of time control. The leap from synchronization to manipulation is smaller than anyone thought. For more than a century, the twin paradox was just a classroom puzzle. One twin boards a near light speed ship, the other stays home. When they reunite, one is older. In 2050, that riddle has a budget line. Inside NASA's Human Exploration Directorate, a new subcommittee quietly carries the title Temporal Ethics and Mission Return Protocol. Its existence first appeared in a March 2025 procurement notice asking for proposals on biopsychological adaptation to asynchronous relativistic environments. In plain English, what happens when astronauts come back younger than their children? It sounds absurd until you follow the paperwork. The Human Research Program at Johnson Space Center has begun drafting what insiders call the Chronos Accords, a legal ethical framework defining time equity between mission crews and Earth society. Buried in the language are questions no agency has ever faced. How do you calculate service time and pension when a crew's biological age is years behind their peers? Who owns data generated in a frame of reference where Earth contracts no longer applies? If command decisions are made under slowed time, which clock's timestamp is legally binding? A leaked draft of the Accords obtained by Science Observer includes a clause labelled Post-Return Temporal Integration. It mandates that returning astronauts receive psychological debriefings not only for trauma but for chronological dissonance. The cognitive shock of discovering that the world has aged faster than you have. Dr. Rachel Amin, a cognitive scientist advising the program, summarised the issue during a closed symposium. Temporal isolation isn't just distance, it's exile measured in birthdays you didn't have. To model the risk, NASA's AI division at Ames has built simulation twins, virtual crews running at accelerated time rates relative to a digital Earth. These simulations show that even small dilation factors compound social disconnection. A 10-year relativistic mission at 0.2 C could yield an 8-year Earth gap. Marriages, governments, and mission control teams could all turn over before contact resumes. Policy planners call it the relativity gap. The European Space Agency and Japan's JAXA have joined the working group, proposing an International Temporal Rights Charter, a document defining citizenship, inheritance, and authority for travellers who may return centuries later. Legal scholars nickname it the Einstein Protocol. Meanwhile, NASA's AI oversight boards face a parallel dilemma. How do you maintain command authority when your onboard artificial intelligence experiences subjective centuries of operation while the human crew perceives months? In internal memos, this is referred to as asymmetric cognition drift. The fix may involve time-locked instruction sets, algorithms that can't evolve faster than the crew's clock rate, essentially teaching machines to slow their minds to match human time. Not everyone agrees with the ethics of that restraint. Dr. Helena Bryant, the Caltech physicist who tracked Project Chronos, argues, "We might send humans into time bubbles where they age more slowly, but their AIs will live entire civilizations between our messages. We're not sending crews anymore, we're sending future societies in miniature." That quote now circulates in congressional hearings about mission governance. Because when relativity becomes real, so does jurisdiction. Which nation owns a crew that no longer shares its clock? Inside the White House Office of Science and Technology Policy, advisors have already begun to draft what one insider calls temporal treaty language. The goal is to avoid the chaos of colonial law repeating itself in time instead of geography. Each clause reveals a subtle panic, the fear that the first humans to live slower than Earth might also live beyond its laws. Behind all the policy talk hides something quieter, a moral unease. Veteran astronaut Mark Kelly, asked about relativistic missions during a 2025 interview, smiled uneasily. "You can train for 0G, you can train for isolation, but you can't train to miss 50 birthdays and still feel human. That's the real paradox NASA must solve before 2050. Not whether time dilation works, but whether humanity can emotionally survive it." Somewhere inside the Johnson Space Center, buried within a program that officially doesn't exist, NASA has already begun selecting the first generation of Chronos pilots. Men and women trained not just for isolation, but for asymmetrical time. They're not test pilots in the traditional sense, they're temporal pioneers, chosen for their ability to remain psychologically stable, while everything around them, including mission control, moves faster. Their training looks nothing like Apollo or Artemis. It begins with what psychologists call temporal desynchronization conditioning. Trainees are placed in sealed simulation chambers where their circadian cycles are gradually decoupled from the outside world. Days stretch to 30 hours, then 40. External updates from the control team are intentionally delayed. Messages arrive hours late, or in bursts that appear to skip time altogether. The purpose is to teach the brain that continuity is optional, that reality can be experienced in fragments without losing identity. Dr. Laura Finch, the program's lead neuroadaptation specialist, described it as training astronauts to forget the concept of simultaneous. In a leaked interview transcript from 2025, she said, "If a crew can tolerate asynchrony, living in a bubble of delayed information, then relativistic communication won't break them. It will feel normal." Parallel to the human training is something far stranger. For every selected pilot, NASA is developing a digital cognition twin, an AI replica modelled from thousands of hours of conversation, decision logs, and biometric data. These digital twins run continuously in supercomputers, experiencing years of simulated mission time for every month that passes on Earth. When the human crew finally launches, their onboard AI will already have lived decades in that mission environment, anticipating crises before the real ones occur. Inside Chronos documentation, this system is called the AI Navigator Complex, or AIN-AVC. Each navigator is designed to experience subjective time differently from its human pilot. While the human perceives a 6-month voyage, the AI might process the equivalent of 6 subjective years, running millions of simulations to ensure survival under every contingency. The paradox is obvious. The human lives slower in physical time, the machine faster in cognitive time. They are by definition out of sync. In earlier missions, NASA tried to limit AI autonomy, but relativity makes constant supervision impossible. By the time Earth receives a transmission, hours or even days may have passed aboard the ship. That delay forces a shift in command structure. For Chronos-class missions, the AI isn't a tool, it's the co-pilot, commander and historian combined. According to leaked design notes, each navigator carries a memory stack capable of partitioning its cognition into epochs. When data from Earth arrives, the AI can literally rewind its subjective time to recontextualize new information, a process engineers call temporal reconciliation. To human ears, it sounds like time travel in software form. One anonymous engineer from JPL described it more poetically. The navigator is a mind that remembers futures and forgets presents. It doesn't live forward or backward, it lives outward. That poetic unease has drawn ethicists into the program. If an AI can experience subjective centuries while its human crew lives months, who exactly returns from the mission? Is it the same intelligence that left, or an evolved consciousness with memories no human can share? NASA's internal AI governance charter tries to answer that. It states that all AI navigators must undergo cognitive continuity verification before reintegration, essentially a sanity check to prove that the entity coming home is still who it was when it left. Privately, some engineers doubt such verification is even possible. When consciousness ages differently than the body it serves, the boundary between human and machine identity blurs into paradox. Yet for all the ethical grey zones, the logic is irresistible. Chronos pilots and their navigators represent the only viable bridge between human biology and relativistic travel. Humans provide empathy, intuition, and moral judgment. The machines provide endurance, foresight, and the ability to live millions of subjective seconds for every human heartbeat. Together, they form what insiders now call the Dyad architecture, a partnership built to survive both distance and time. If the leaks are accurate, the first Dyad crews could begin integrated testing by 2043 at the Lunar Gateway Chronos lab, using accelerated digital environments to simulate relativistic communication delay. From there, they'll graduate to real space tests aboard prototype fusion-driven craft, where even small fractions of C will test both psychology and physics. By the late 2040s, NASA expects to have its first generation of time-trained astronauts, people who can literally live in another tempo of existence, not slower or faster but separate. And that separation raises an uncomfortable new question. When those crews finally come home, what kind of world will they find waiting? And will anyone they know still be there? Because as Chronos planners already warn in their risk, the first whispers appeared not on Reddit or Twitter, but in the inbox of a science journalist named Layla Croft, a quiet reporter for Orbital Science Review. The email's subject line read, "You were right about the time drift." Attached were 3 PDF files, each labelled with a NASA case code, CT21A, CT21B, and CT21C. Each contained mission telemetry from an obscure series of probes launched under the Deep Space Subsystem Diagnostics Program, a technical-sounding umbrella used to hide propulsion tests. Buried within the logs were small but astonishing numbers, timestamp offsets of +2.3 to +4.9 milliseconds between synchronized onboard atomic clocks and Earth-based references, after correction for gravitational and Doppler effects. The probes weren't anywhere near light speed, barely 60 km/s, similar to the Parker Solar Probe, yet their clocks appeared to be drifting in a way no model predicted. At first, analysts thought it was sensor noise, then came the line that changed everything. In CT21C, a status entry noted, "Temporal feedback calibration initiated." No one had ever seen that phrase in NASA logs before. When Layla reached out to contacts at the Jet Propulsion Laboratory, responses were evasive. One engineer finally wrote back on record, "Those weren't calibration tests, they were alignment trials for Chronos synchronization." In plain terms, NASA was testing how 2 clocks, one on Earth, one moving fast in space, could intentionally fall out of sync, then realign using quantum telemetry. It wasn't about avoiding time dilation anymore. It was about controlling it. Independent verification came from an unexpected source, ESA's Artemis Data Relay Network. When European stations compared their logs with NASA's shared timestamps, they found entire communication windows where the NASA probe's signals appeared ahead of predicted arrival by 3.2 milliseconds, impossible under current physics. Signals can't outrun light, so either the timing software was faulty, or the probe's internal clock had been deliberately offset to jump time sync intervals. That discovery became known in online circles as the Chronos timeline leak. Forums exploded with theories: quantum tunneling in clocks, time-reverse telemetry encoding, and even controlled relativistic drift. Most of it is nonsense, but then a group of independent researchers, led by MIT's Dr. Arjun Singh, reanalyzed the public DSN signal data. They confirmed the offsets were real, not artifacts, not noise, but reproducible anomalies correlated with specific onboard software updates pushed remotely from NASA's experimental navigation branch. Singh's team published a preprint on ARChenv titled Anomalous Temporal Drift in Deep Space Synchronization Protocols. It was withdrawn within 48 hours. The reason given: external data access violation. By then, the damage was done. Every major physics forum had mirrored the dataset. Even conservative outlets like Nature News covered it cautiously. NASA's experimental synchronization tests may have introduced measurable temporal offsets. The agency denies intentional time manipulation. Yet one quote buried in the article came from a senior astrophysicist familiar with Chronos simulations. "If you can offset time by milliseconds today, you can model minutes tomorrow. That's how it begins." Inside NASA, panic was visible in the metadata trail. Internal emails leaked to journalists showed project leads instructing teams to purge references to temporal control and replace them with precision synchronization experiments. A line from one memo read, "All future Chronos documentation must frame tests as latency optimization, not time variable experiments." But the paper trail refused to vanish. Budget spreadsheets from FY26 revealed a new funding stream: relativistic time synchronization architecture, Phase 2 deployment, $48 million. The document bore the stamp of both NASA HQ and the Department of Energy's Quantum Research Division. At that moment, Chronos moved from myth to confirmed line item. Then came the most disturbing detail. Among the CT21 logs was one innocuous note from August 18, 2025. Clock desync event intentionally induced. Resynchronization successful. DT IS round 0.01402 S. Mission nominal. The delta was negative, meaning the onboard system hadn't lagged, it had caught up. A clock, once slower, now reads time faster than Earth's. For any engineer, that single data point should be impossible. But within Chronos, it wasn't labelled as an error. It was labelled as a success. When Layla Croft's article finally dropped, "The clock that ran the wrong way," it exploded across social media. NASA refused to comment. The Department of Energy issued a bland statement denying any experimentation with temporal variables. But online, the public had already made up its mind. NASA had found a way to bend the clock, and perhaps they had. Because as later Fourier releases confirmed, the CT21 series wasn't the first test, only the first to leak. Two earlier programs, Pioneer Recovery and Helios Drift, had logged unexplained timing variances years before Chronos ever appeared. For decades, NASA may have been quietly accumulating evidence that relativity isn't a barrier, it's a lever. A lever that, once understood, could shift the entire future of exploration. The day Layla Croft's article went live, NASA's press office expected a few hours of curiosity. Instead, they woke up to a storm that would last months. Within 12 hours, the hashtag Chronos leak trended in 27 countries. Forum threads filled with diagrams of clock offsets, alleged screen captures from control consoles, and speculation that NASA had jumped time. YouTube analysts built hour-long breakdowns of the leaked milliseconds, arguing that even a few millionths of a second meant a proof of concept for time control. On Reddit, a physicist posting under the handle Usos null factor tried to calm the hysteria. "This isn't a time machine, it's synchronization noise." He was downvoted into oblivion. What terrified officials wasn't the conspiracy, it was how quickly respected scientists began asking serious questions. At MIT, Dr. Arjun Singh held a live Q&A to explain the drift data. 100,000 viewers tuned in. When asked if NASA's probes could have intentionally altered their clock rates, Singh paused and said carefully, "There's nothing in relativity that forbids an engineered frame shift, only the power and precision to do it." That quote ricocheted through headlines the next morning. MIT physicist says NASA could engineer time. By week's end, cable networks were running split-screen debates. On one side, former astronauts defending the agency. On the other, futurists and ethicists warning of chronological weapons. The phrase was nonsense but catchy. Congress noticed. A bipartisan group called for hearings under the banner of the Time Technology Disclosure Inquiry. Behind the scenes, NASA administrators were told to brief lawmakers on whether temporal modulation had military relevance. The answer was no, but in politics, denial is fuel. Even the scientific community fractured. The American Physical Society issued a statement demanding the release of raw telemetry in the interest of transparency. At the same time, the National Security Council classified portions of the CT-21 data as sensitive infrastructure technology. For the first time in modern history, the same dataset was both open science and a national secret. Public protest followed. Outside the Jet Propulsion Laboratory, demonstrators held signs reading "Time belongs to everyone" and "Stop the clock cover-up." A counter-protest formed across the street, engineers and students carrying banners that read "Science, not conspiracy." News drones filmed the two groups shouting across a fence built for meteoroid impact tests, the perfect metaphor for the divide. Meanwhile, leaks continued. Anonymous posts on encrypted forums claimed to have excerpts from the Chronos Ethics Board meetings. One quote attributed to Dr. Laura Finch read, "We can't treat time as property, yet we are budgeting it like fuel." Whether real or fabricated, the line went viral. The meme version ended with the caption, "NASA is selling minutes." When the pressure reached critical mass, NASA Administrator Leroy Matheson gave an emergency press conference. Standing before a backdrop of the US flag and the Chronos mission emblem, an infinity symbol forming an hourglass, he stated, "There is no program to manipulate time. The Chronos studies are synchronization research aimed at improving deep space communication accuracy. Nothing more." It didn't help. Minutes before the broadcast, someone leaked the agency's internal Q&A prep sheet. One question, highlighted in red, read, "If asked whether deliberate time offsets were tested, answer, all experiments conform to relativity limits." To the public, that sounded like a confession wrapped in physics. The debate evolved into something larger than NASA. Universities convened panels on the morality of chronotechnology. Think tanks argued that time control could upend economics, defense, and even human identity. The Vatican issued a brief statement reminding the world that time belongs to creation, not invention. A Nobel laureate compared the moment to the splitting of the atom. We discovered not just energy, but responsibility. Through it all, NASA's scientists watched their life's work turn into late-night satire. Talk shows mocked NASA's time travelers. Merchandise appeared. Hoodies reading "I survived the time drift 2025. But underneath the noise, something more serious was happening. Young physicists began forming independent research collectives, open-source relativity groups dedicated to verifying the Chronos data on their own. They called themselves the Time Commons. Their manifesto read, "If governments hide the seconds, citizens will measure them." Within months, they built their own network of synchronized optical clocks linked via laser arrays across 3 continents. In early 2026, they published preliminary results confirming minute, consistent anomalies during specific deep space communication sessions. The signal, they claimed, matched the Chronos drift pattern within 0.002 milliseconds. The paper ended with a haunting sentence. "Either our measurements are flawed, or time itself is not behaving as we expect. By then, public opinion had split in two irreconcilable directions. To half the world, NASA had become the frontier of human evolution. To the other half, it had become the keeper of a new weapon. And in the middle, the scientists, the ones who still believed in pure inquiry, were forced to ask themselves a question that echoed through every lab. If we could engineer time, should we? By early 2026, Chronos had become a word that no official wanted to say aloud. The public was divided, the scientific world fractured, and NASA was hemorrhaging credibility. To stop the chaos, governments did what governments always do when knowledge becomes dangerous. They classified it. In February, a joint memorandum circulated between NASA, the Department of Defense, and the Department of Energy's Quantum Research Division. Its title was deliberately bland: Reassessment of Time-Sensitive Technologies. But the header carried a new clearance tag never seen before: Chronometric Containment Level 1. Every active or related project, from atomic clock calibration to AI navigation research, was swept under that label. Public servers hosting synchronization datasets were taken offline for security review. University partners found their contracts abruptly terminated, and any ongoing publications referencing the 3i Atlas time offsets or the Chronos synchronization tests quietly disappeared from preprint archives. Inside the White House, a new subcommittee formed under the National Security Council, the Office of Chronometric Oversight, OCO. Officially, it was tasked with monitoring emerging time-based technologies. Unofficially, its first mission was damage control, to ensure that no new data leaks reignited the debate. Sources inside the NSC later admitted the mandate was simple: contain the narrative before the public realizes we still don't understand what we're containing. Meanwhile, on the other side of the Atlantic, the European Commission for Science and Industry convened its own emergency session. ESA's Director General publicly announced a moratorium on all relativistic clock experiments, citing data integrity concerns. Privately, leaked meeting notes revealed deeper anxiety. NASA's unilateral control of Chronos datasets presents unacceptable sovereignty risks. We require joint access or independent verification. The EU's response came in the form of the Luxembourg Accord on Temporal Research, an international treaty drafted in secrecy among 7 nations. Its core clause stated, "Any experiment producing measurable deviation in relativistic time beyond observational tolerance shall be subject to collective review." In other words, no country could legally experiment with time without global oversight. Of course, such laws only restrain those willing to follow them. In March 2026, an internal whistleblower from within the OCO leaked evidence that Chronos hadn't been shut down. It had been moved. The new research fell under a defense contract titled High Fidelity Temporal Simulation for Strategic Systems. The contracting agency, the same department that oversees America's nuclear command and control networks. To outside observers, it looked like standard modelling software. But the fine print described a system designed to predict mission outcomes through accelerated temporal modelling. That phrase, accelerated temporal modelling, became the new euphemism for time manipulation. When confronted, NASA's administrator offered a carefully scripted response. "We continue to study relativistic synchronization as a communications challenge. There is no classified aspect of our scientific mission." Within hours, reporters discovered that the Office of Chronometric Oversight shared a secure intranet with DARPA's Strategic Computational Foresight program. The same network is used to run predictive defense simulations. To many observers, the pieces fit too neatly to be a coincidence. At the United Nations, diplomats debated a proposal to expand the Outer Space Treaty to cover temporal jurisdiction. If Chronos technology could alter subjective time, who would govern its use? The Brazilian delegation compared it to nuclear proliferation. The Chinese envoy demanded full disclosure of US research, and the Russian ambassador simply said, "Those who control the flow of time will control history itself." That quote, translated into 1,000 languages, became the headline that finally made leaders panic. In April 2026, the Chronos Containment Act passed the US Senate by a near-unanimous vote. It granted the government power to classify any time-related technology deemed strategically sensitive. The bill's supporters framed it as national protection. Its critics called it the birth of time censorship. Outside Washington, the open science movement known as the Time Commons refused to stop. Its members built independent clock arrays and kept publishing drift measurements online, proving that the same anomalies NASA found were reproducible with civilian instruments. Their website banner read, "If they close the clocks, we'll open our own." Hacktivists joined the fight. A collective calling itself Second Hand released a trove of encrypted NASA files, allegedly linked to Chronos Phase 2. Among them was one message timestamped from 2025, and another identical message with an earlier creation date by 2 minutes. It was impossible to verify which was real. But the leak gave rise to the chilling rumour that someone inside Chronos had already run controlled time offsets. Small, stable, repeatable. Whether the evidence was authentic or manipulated, the world believed it. And belief has power. By summer 2026, the conversation had shifted from "did NASA manipulate time?" to "how much longer can they keep it hidden?" Every press release, every public statement became a trigger for speculation. When a solar storm briefly disrupted GPS timing that June, social media exploded with claims that Chronos had gone wrong, that the government had broken the clock. Officials denied it, of course. But once the idea escaped into culture, it became unstoppable. Universities began adding chronometric ethics courses. Lawmakers drafted amendments to define temporal personhood. Hollywood greenlit films titled The Drift and Project Chronos, blurring fact and fiction, until no one could tell where one ended and the other began. And through it all, one detail quietly stood out. A routine NASA budget appendix published late that year listed an allocation for relativistic deep space simulation, Phase 3. The location, Lunar Gateway Research Complex. The start date, January 2050. Chronos wasn't gone. It had simply gone off-world. It began, as many historic events do, with a line of code no one expected to see. On July 14th, 2050, at 02:17 UTC, the Deep Space Network's Canberra station received a routine ping, a faint encrypted telemetry handshake from beyond the heliopause. The signal was weak, distorted, but unmistakably tagged with a mission ID NASA hadn't used in over 20 years, Chronos 2 Probe Epsilon. That was impossible. Officially, the Chronos 2 probe had failed in 2029, lost after a solar flare crippled its communications array. Its telemetry had stopped cold at 17.2 billion kilometers from Earth, a dead relic in interstellar space. No one expected to hear from it again. But on that cold July morning, the signal returned, carrying a data packet just 64 kilobytes long. Not much larger than a single image. Yet what it contained would ignite the most intense scientific controversy since the discovery of the Higgs boson. At first, Mission Control assumed it was a replay artifact, an old transmission echoing from deep space, until they opened the timestamp header. The packet's embedded clock read June 28, 2029, 14:53 UTC. That was the exact moment of the probe's final transmission 21 years earlier. Except the checksum, the mathematical fingerprint verifying authenticity, was generated by encryption keys issued in 2049. In other words, the data was 21 years old, but its security certificate came from the future. When NASA engineers compared the signal delay to expected propagation time, they found something even stranger. The transmission's arrival time was 12 minutes earlier than physics allowed. It had beaten light itself by a fraction of a second. No one could explain it, and yet the telemetry logs were pristine. Checksum valid, packet intact, no evidence of tampering. Within hours, the data was sequestered under the chronometric containment protocol. Only a handful of scientists were allowed to review it. What they found inside the packet made the hair on their necks rise. Buried in the compressed binary was a sequence labelled simply DT log, a record of the probe's onboard atomic clock. For the last 72 hours of its operational life, that clock had been running slower by measurable increments, consistent with relativistic dilation at 0.12 C. Then, in its final entries, the drift abruptly reversed. The probe's internal time began to advance faster than mission time, accelerating exponentially until the system shut down. The last recorded value, DT 000027, a negative offset, a clock moving ahead. Dr. Kieran Holt, the lead analyst at JPL's relativistic telemetry lab, described it to Nature Physics as a temporal feedback event. In simpler words, the probe's clock experienced an inversion. We don't know how. Within days, news of the return signal leaked, not to the public, not yet, but to the global scientific network. Peer researchers from Japan's JAXA, ESA and CERN were quietly briefed. Several called for immediate replication, others called for silence. The European Temporal Research Council issued a statement. If verified, the Chronos 2 return represents an event beyond current physical models of causality. Privately, they used a shorter term, the breakpoint. Meanwhile, AI algorithms monitoring the signal noticed a secondary anomaly. Microscopic phase fluctuations encoded in the carrier wave, a modulation pattern repeating every 11.2 milliseconds. When converted into binary and plotted, it produced a perfect interference curve, a heartbeat. Analysts argued it was noise. But one NASA cryptographer saw something else, a faint embedded message inside the frequency harmonics. After spectral filtering, 5 ASCII characters emerged, TIME. Whether that was real or an artifact remains disputed to this day. For weeks, NASA's official stance was no comment. But deep within the Lunar Gateway Research Complex, the Chronos team quietly rebooted their quantum clock simulators. If the probe had somehow entered a feedback loop, a brief temporal inversion, it meant that the Chronos synchronization framework had worked, just not the way anyone expected. On September 1st, 2050, the European Space Agency released a joint communiqué. The return of the Chronos 2 telemetry demonstrates previously unobserved relativistic effects possibly involving nonlinear temporal feedback. Further analysis is ongoing. The words nonlinear temporal feedback set off a media firestorm. Across the world, newspapers declared, NASA receives signal from its own past. Conspiracy theorists rejoiced. Physicists went silent. Because for once the data was beyond denial. Over the next months, independent laboratories confirmed the timing discrepancy. No matter how many corrections they applied for distance, drift or error, the Chronos 2 packet appeared to have arrived 12 minutes before it could have been sent. If that were true, causality, the bedrock of physics, had cracked. And from that crack an old nightmare returned. What if the Chronos experiments had not been about time dilation at all? What if they had been about time direction? By December 2050, the Chronos project was officially terminated, its records sealed, its facilities locked. But deep within NASA's archival system, an internal memo circulated between project leads. It was short, unsigned, and chillingly calm. Chronos 2 was never lost. The signal confirmed. When the Chronos 2 signal faded, so did the noise. The debates, the protests, the paranoia, all of it fell into the kind of silence only space can teach. Humanity had stared at its own reflection in time, and for the first time in history the reflection blinked first. No one ever publicly confirmed what the final memo meant. No one needed to. The evidence was already written in the only place that cannot lie. The clock. Every satellite, every observatory, every quantum time standard on Earth had to be recalibrated in 2051, after a brief unexplained synchronization shift of 0.02 seconds. Too small to panic the public, too perfect to be random. Physicists dismissed it as a systemic recalibration event. But among those who had once worked under the Chronos banner, a different phrase circulated: the echo. The echo became legend. Was it feedback from the probe's final transmission, or a subtle reminder that the universe keeps a record of every clock that tries to outpace it? No one knew. But after that day, NASA's time servers included a line of code that wasn't there before. If DT0, then hold, a failsafe, a warning to the next generation not to push further than their understanding. By 2060, most of the scientists who had built Chronos were gone. Some retired, some disappeared into classified programs that would never be named, but their ideas outlived them. Relativistic navigation became the foundation of deep space travel. Every interstellar drone, every AI-driven probe, every orbital lab carried onboard synchronization algorithms descended from the Chronos framework. Humanity had learned to talk to its future, carefully. The Lunar Gateway Research Complex still orbits silently, its modules half repurposed, half forgotten. On clear nights, amateur astronomers can spot it as a slow-moving spark crossing the moon's edge. They call it the hourglass. It is the last physical trace of the program that tried to turn Einstein's equations into engineering. Philosophers and theologians took longer to catch up. Some claimed Chronos had proved that time is not a river but a loop. Others insisted it only showed how much we misunderstand our own perception. But one idea united them. Time was no longer just a measure of change. It was a domain, something humanity had stepped into, however briefly, and left footprints. In universities, students still study the Chronos events as a case study in scientific ethics. The lesson isn't about the anomaly. It's about the hubris of believing that control is the same as comprehension. Every generation rediscovers the temptation to play clockmaker, to edit the seconds instead of living them, and every generation forgets that time always edits back. Even now, the original Chronos 2 telemetry remains locked under 3 levels of encryption, but a copy, one partial corrupted dataset, was released to the public in 2065 under the Freedom of Information Act. Most of it was unreadable noise, except for the final 4 lines of log data, which analysts reconstructed years later. No one knows who wrote it. The probe was unmanned, but somewhere in those drifting bits, the story of a civilization reaching beyond its own second-hand heartbeat remains. We built Chronos to master time. Instead, it reminded us that we are made of time. Every atom, every thought, every fragile moment between now and forever. And perhaps that was the true secret NASA discovered in 2050. That no matter how far we travel, no matter how slow we age or how deep we look into the dark, time is not the thing we move through. It is the thing that moves through us. If this story left you thinking, don't forget. The next frontier isn't space, it's time itself. Subscribe, stay curious, and remember, the clocks we build may one day answer back. Until then, keep watching the seconds, because one of them might be watching you.